Problem 11. 5 big elephants and 4 small ones are walking along a path as shown. When they reach the junction, each elephant turned either to the left or to the right. Which of the following cannot be a situation after they all pass the junction? These are our options. So let us move our elephants. First option. So we have a big elephant that should go here, smaller one this side, the big elephant this side, big elephant this side, and the smaller towards the left, bigger one towards the right, and then we have smaller ones towards left, right, and left. So let's see. So we have one big elephant, 4 small elephants onto the left, and we have 4 big elephants on the right. So this is not our answer. Let us clear the screen. Option B. So we have 2 elephants big, so we go left and then small one right and then left and then right, the big one. We have 2 small ones here, so we go one towards left, we go right, left, and then we have 2 towards the right. So we have 2 big elephant on the left and 2 small, and the rest is in a sequence small one, the 3 big ones. So we have 3 big ones and a small one. So this is also not our answer. Option C. So we have a big elephant going towards left and then a small ones towards left, and then we have 2 big ones going on the right. We have 1 small ones going, so we are done with this one, and big one elephant done. Now we have 1 big one going on to the right, so we are done all here. Then we have 1 small going in here, and there is no way, so we are done with this. So there is no way a small one can go. It should be a reverse direction. So this could be our answer, option C. Option D. So we have a big elephant going this way. We have a small one going down. So we are done with these 2 elephants. And then we have 1 elephant this way. And let us have another big elephant towards right. So we are done with these. And then we have small one going towards right, and then let's have the big elephant goes onto the left side. Then we have the small one here, then we have the big one here, and then goes the small one. So this is possible, so it could not be our answer. Option E. We have a big elephant. Let's take it towards right, and then a small elephant. Then we take 2 big elephant towards left and a small one towards left. And then we are done with 2 big elephant and a small one, and 1 big and small elephant. Then let's take on either left or right. So we pick left, these 2, and then this 2 onto the right. So this is possible solution. So we cannot have option E. So our answer is option C is our answer. Problem 12. Clara starts with the number 12 and follows the arrows shown in the right diagram while performing the operations using the rules shown in the left diagram. This is the left diagram. What number will she finish with? These are our options. This one is a tricky question. So instead of doing all the math right away, here is my smart tip. Mark these arrows with the operations first, then look to see if some numbers cancel each other out. That way you don't get lost in the math. You just solve what's left at the end. Trust me, this makes it way easier and helps avoid silly mistakes. So let us start. So we have first operation. 12 coming down, that means we multiply by 4. We are going right, that means we multiply by 2. We come down, that means we multiply by 4 again. We're going left, that means we divide by 2. We come down, multiply by 4, goes left, divide by 2, goes up, divide by 4, left, divide by 2. We go up, that means we divide by 4. We go towards right, that means here multiply by 2. We go up, that means we divide by 4. So here we see, if we have divide and 4, do they cancel? Yes. Divide is 1 by 4 and multiply is 4. So they cancel each other. So we cancel these. We have multiply 4, divide by 4. We have multiply and divide, we cancel. Now we have multiply by 2. We cancel with divide by 2. We have multiply by 2, cancel with divide by 2. Is there anything left? Divide by 2 only. So we divide 12 by 2 gives us 6. So our answer is option B, 6. Problem 13. The year 2022 is a special year because the digit 2 appears 3 times. This is the third time Eva, the tortoise, has lived such a year with 3 identical digits. What is the youngest age that Eva could be by the end of 2022? These are our options. We need to find the youngest age that Eva, the tortoise, could be by the end of 2022, given that she has experienced 3 years with 3 identical digits. So identical digits are these. So for this problem, we will go backward. We will start from 2022 and then we see which are 3 identical digits in a year. So we start 2022, where the digit 2 appears 3 times. Now the next year, before 2022, with 3 identical digits will be 2000, where the digit 0 appears 3 times. Now going backward again, the first year with 3 identical digits will be 1999, where 9 appears 3 times. So Eva has experienced 1999, 2000 and 2022. If Eva was born in 1999, she would have been 0 year old here. In 2000, she will be 1 year old. And in 2022, she may be 23 years old. So our correct answer is option D, 23. Problem 14. A rectangular based water tank has dimensions 1 meter by 2 meter by 4 meter. This is the one we are referring. It contains water to a depth of 25 centimeter. So this is the depth, as shown in the left hand picture. The tank is turned so that a 1 meter by 2 meter face becomes the base. So this is the base, as shown in the right hand picture. What is the depth of water now? So this is the depth, we have to find it out. These are our options. So let us figure out how much water is in the tank. Now, first thing, let us determine the volume of this water in this cuboid. Before we do that, let us look into the unit. So we have dimensions in meter, but here we have depth in centimeter. So we have to convert this centimeter into meter to make it a proper calculation. So when we have to convert from a smaller unit to a bigger unit, we divide. So we divide by 100 because 1 meter is equal to 100 centimeter. So we divide 25 centimeter by 100 makes it 0.25 meter. Now we have depth, we have length and width. So the volume of the water will say length into width into height. So we have length, that is 4 meter, 2 meter width, and height is 0.25 meter. And that makes it 4 to the 8, 8 into 0.25, 2 cubic meter. Now we have the volume of the water. So let's clear the screen. So we have volume of the water, that is 2. We know the length is 2 meter times width is 1 meter, and we have to determine height, and this is the height. So it becomes an equation for us. Now we divide by 2 on both sides, and what does it make? It will make height is equal to 1 meter. So our answer is option D, 1 meter. Problem 15. The picture shows a piece of transparent paper with a design drawn on it. The paper is then folded twice as shown. So this is the fold paper which is being folded from top to bottom and from sideways. What would be seen on the folded paper? These are our options. Let us go step by step and fold the paper and see how it looks. So we have this paper. We will bring down this side and it comes down as this way. So the square comes this way and this and the design. Now we fold and bring this side on top of it. So what will happen is we will have the triangle like this and see how the design comes on it. So we form this design. Let us see which one matches. So we have option A that matches, C that goes different, no, not possible, E not possible. So our answer is option A. Problem 16. Jessie writes 7 numbers 3, 4, 5, 6, 7, 8 and 9 in the circles in the picture so that the sums of the 3 numbers on each line are equal. What is the largest possible sum of 3 numbers on a line that Jessie can get? These are our options. So very first thing, let us name this circle as this. So we name this circle A, B, C, D, E, C and F, G, C. And these are all needs to be same. So we have 3 lines in here. We have line 1, A, B, C, line 2, D, E, C and line 3, F, G, C. Now if we add these numbers in 3 lines, so we will get A plus B plus C, D plus E plus C, F plus G plus C. That means we will get 3C. So it will look like this. We add and we get 3C. Now we know that the sum of these numbers are 3 plus 4, 7, 7 plus 5, 12, 12 plus 6 gives 18, 18 plus 7 gives us 25, 25 plus 8 gives us 33, 33 plus 9 gives us 42. The sum of all these numbers are 42. So what we can do, we can say A plus B plus D plus E, F, G and one of the C will give us 42. So can we write this way? 42 plus we took one of the C from it and it becomes 2C. So the sum of all these will be 42. Now look into the question. What it says that the 3 numbers on each line are equal. That means A plus B, D plus E and F plus J are same. That means can we say S to this, S to this and S to this? So we get 3S which is equal to 42 plus 2C. Now it says what is the largest possible sum of 3 numbers? So the largest number if we assume is 9 and we say that C is the 9, we use that number and see how it calculates and what would be our answer. So 9 to the 18, 18 plus 42 gives us 60. So we got 3s per equals to 60. Now we divide 3 on both sides and we get 20. So our answer is option E, 20. Problem 17. Werner chooses 4 of the numbers 2, 3, 4, 5 and 6 and writes 1 in each box so that the calculation is correct. How many of the 5 numbers could Werner write in the rightmost shaded box? These are our boxes with the operations in here and these are our options. Let us try combinations that results in each number from the set being the shaded box. So we will try first 2. So how we will calculate so that we will get answer 2. Can we mark it as 3 plus 5 gives us 8. 8 minus 6 gives us 2. So that means 2 could be possible. Now let us try with second possibility, 3. So we put 3 in this box and now we have to find a calculation that would result to 3. Can we say 5 plus 4 gives us 9 and 9 minus 6 gives us 3? So this is also our option. Now let us try 4. Can we say 5 plus 2, 7. 7 minus 3 gives us 4. So 4 is also possible. Let us try 5. We say 6 plus 3 gives us 9. 9 minus 4 gives us 5. So this is also our option. Now let us try last number 6 in the shaded box. We say 4 plus 5, that is 9, and 9 minus 3 gives us 6. So all these numbers are the possible options in the shaded area. So our answer is option E, 5. Problem 18. Andrew wants to complete the picture so that each row, each column and each set of 4 circles connected by line segments contains the 4 numbers 1, 2, 3 and 4. What number should he write in the circles containing the question mark? These are our options. Let us try to solve this problem and pick the number and fit it in here. So what it says that this connected lines should contain 1, 2, 3, 4 and each row and each column should have only 1. There is no repetition of these numbers. So let us solve this problem. So we know here we could put 4 and when we have 1, 2 and we can put 3 here. So we got our 1, 2, 3, 4, all the numbers. Since we got 3 in here, 4 in here, we would get 3 in here. Now there is a possibility that we could have 4 in here. Since we cannot have 4 here, so we will have 1 in here now. So we have 1, 2, 3, 4 and one circle. Now looking into it, we could say that we could have 1 in here because we need all these 4 numbers in this connection. So we would have 1 in here. Now in this row, we have only number missing is 2. So we will have 2 in here. So our answer is option B, 2. So let's see the entire solution. So this is the entire solution filled with these numbers. Problem 19. Lisa has 4 dogs. Each of the 4 dogs weighs an integer number of kilograms. No 2 of the dogs weigh the same. Their total weight is 60 kg. The second heaviest dog weighs 28 kg. How heavy is the third heaviest dog? These are our options. Let us form our algebraic equations with whatever is available to us. So we have the sum of all the dogs is 60 kg. So we say first heaviest, second heaviest, third heaviest and fourth heaviest equals 60 kg. Now we know the second heaviest dog weighs 28. That is, this dog will weigh 28 kg. Now we subtract 28 on both sides and we get 60 minus 28 gives us 32. So we have first heaviest, third heaviest and fourth heaviest equals 32. Now pick each options, fit in this equation and see if we can find the third heaviest dog. So we say that the third heaviest is option A, 2 kg. So since third heaviest is 2, the less than 2 would be 1. That would be our fourth heaviest. That means we would say 2 plus 1 is 3 and we subtract 3 from both sides and it makes us 32 minus 3 gives us 29. So the first heaviest is 29. So we have 29 and then we have the second heaviest is 28. Third heaviest, if we say 2, then we have the smallest is 1. So this equation makes sense. So we could say option A is our answer. You could also try with B, C, D and E and see what answers you would get and if it makes any sense. Problem 20. A, B, C and D are points on a line segment with AB is equal to 7, BC is equal to 5, CD is equal to 8, DA is equal to 6. Which two points are the beginning and at the end of these line segment? These are our options. Let us consider our line segment as a path on a coordinates. So this is our path which we have to determine the beginning and end of this line segment. We consider 0, 0 as our center and we mark it as A. Now from A to B we have 7. So we jump to 7. 1, 2, 3, 4, 5, 6 and 7. So this could be our B. We marked it as B. Now we have BC is equal to 5. So we move back and we say 1, 2, 3, 4 and 5. So we mark this one as C. So we mark this BC 5. Now we have CD equals to 8. So CD, that means we go back and we say 1, 2, 3, 4, 5, 6, 7, 8 and we mark it as D. Now we have DA is equal to 6. So it should be D to A should be 6. So we have 1, 2, 3, 4, 5 and 6. So we reach to 6. So this is our path on the line segment. So our end and beginning is D, B or B and D. So our answer is option C, B, D. So this wraps up the part B of 11 to 20 questions from the 2022 Math Kangaroo for grade 5 and 6. If you really enjoy it, please do not forget to subscribe it. See you in the next problem, part C of the 2022 Math Kangaroo for grade 5 and 6.